All right, so like Chris just said, I'm a Sustainable Materials Management Circuit Rider for this year. And so here's a little brief outline of what I'm going to talk about in my presentation. So I'll give a little background at Sustainable Materials Management. We'll keep that pretty short, and I'll jump into the companies. So I went to 4 companies. Carter doubled me. He's way more efficient than I am. But the 4 companies I went to, similar to Carter, keep it confidential. It was a treated earth absorbent manufacturer. So a little bit of linguistic gymnastics here. Then a cabinet manufacturing company and a dairy products producer. That one's fun to say. And then a specialty vehicle manufacturer. So I'll kind of go through the situation, the problem, and then offer my recommendations that I had. And then the potential savings are a little jumbled. I realized I was not very organized when I was going through my presentation again. I was like, man, this is not good. But the summary kind of goes through it again. So if you miss it the first time, it's okay. It's on me. And then we'll have a little bit of questions at the end. You guys are happy. Yeah. All right. So the goal of for my summer was to work with Kansas companies to help them with their waste. And so we've had a couple of people look at this kind of hierarchy of how to handle waste situations, most preferred to least preferred. And of course, we want to reduce at the source, prevent like this material from being used at all. It's just going to go to waste. And then if they have to use it, can we reuse it again? Or can we recycle at some point? So that's kind of a little, kind of the central organizing principle of SMM. So now, Cooper mentioned this earlier, but kind of the 3 things you do is change the material, change the process, change the technology in order to, improve something. And so kind of a little bit of, like, why does this matter? So this is a map of the different landfills in Kansas and throughout all the different counties and where all the waste is going, and then how much life they have left. So obviously, the materials in the landfill, we don't want to be sending it there because they only have a limited life. And if the material still has a use, then let's use it. So that's kind of why this matters, I suppose. So jumping right in, our treated earth absorbent manufacturer. I did kind of 3 different projects with them. They're all kind of similar. So their product uses 2 different minerals. Mainly, there's other ingredients in it, clay and limestone. And so these materials get shipped in by rail, and they're put in these like raw material silos then used in the process. So the processing of these materials to create the product generates dust, and the clay dust is recrushable. So they're able to compact it into usable chunks again, and then reuse it within the facility. But unfortunately, people like to throw trash in the big dust collection sacks. So like these super sacks that have a ton capacity. So when people throw trash in there, you can't really use this dust because there's all this contaminating material in it. And then there's a couple of the dust collection bags that are at the base of the raw material silos, and they're just open to the rain and snow. They're outside. So kind of the recommendations that I came up with, Lena was very helpful with this, was you can get these sacks with lids, basically. They're big polypropylene woven sacks. You can get like a spout top that'll connect to like the feed chute where the dust comes in, and then you can't really throw trash in if there's no place to throw the trash into because it's not open. So then also getting the top will help to close it off to the environment. But you can also add a little bit of roof, that's our recommendation, to the dust chute, and that will help protect the sack as well. And then another thing, just encourage people to change their behaviors, putting a trash can next to these dust collection sacks to go, all right, trash goes here, outside the dust sack. So basically this would allow the facility to reuse 250 tons of clay per year. So it saves, $21,000 on raw material, and then also $44,000 on the disposal cost. So some pretty significant savings on that end. So then the next project with this company was they have a vacuum system that cleans the facility. It's just stuff will like get swept up into the vacuum points, they'll suck it up and put it inside, one of these big super sacks. And this generates a bunch of waste from cleaning the facility. Obviously, you have a lot of debris, little wood chips and screws and whatnot, but it's almost close to 500 tons per year. So very significant. Now, this material is going to take a little bit of testing because we're not even sure that it's recrushable, if they can compact it into usable material. But if they can, then they're going to be able to reuse it and save, $41,000 on raw material costs by reusing it. Of course, they're going to need to separate out the debris inside their grate or some sort of mesh. So they're going to have to do some testing on that to see what size of contaminated material it is. But then, obviously, the disposal cost is very significant that they're saving if they're able to reuse it, $86,000. And then kind of a backup plan that the company has. They've been talking with a waste energy company, and so they'll be able to burn that in order to create some energy. So then the third thing I did at this treated earth absorbent manufacturer was the limestone dust. And limestone dust is not recrushable, doesn't agglomerate. This is a word I like, so it doesn't get, doesn't clump up. So they can't reuse it within the facility. It's fortunately less than the clay or the vacuum dust, about 190 tons per year. But they're still going to be able to save a lot on the disposal cost if they provide it to other companies. Limestone is used in a lot of different things, commonly used in cement. In the local county hazardous waste disposal facilities, even interested in a small amount of it the limestone is base, so it'll help to neutralize household acids. So $33,000 in disposal costs if they're able to get it to some company. So that's a pretty significant deal, even though they're not able to reuse it. Then someone else is able to recycle it. All right, so moving on to the second company, the wood cabinet manufacturing company. And so the project I did there was doors that are not up to quality cabinet doors. Those just get thrown away. And what they do with the rest of their wood waste, their offcuts, their sawdust, is they shred it up in a wood chipper and then they give it to a wood shavings company. And this company takes that away for free. But otherwise, they dispose of the rest of their waste for about $198 per ton. So they're spending about $198 per ton to get rid of all these bad cabinet doors. And they can't shred up these cabinet doors because of the metal hardware and the nuts, not the nuts, sorry, the nails and the staples that hold the cabinet pieces together. So how do they get rid of that metal? Well, they can still shred it. The shredder is capable of shredding these doors that have the metal pieces inside them, but they just need a magnet belt in order to remove them. And so that would save about $12,000 in disposal costs a year from that 63 tons of wood going to landfill each year. So pretty significant amount of material. And this doesn't even include like some benefits of being able to recycle those metal pieces that they would pull from the cabinets. All right, so on to the third company, the dairy products producer. So I also had 3 projects with this company, and they're a smaller operation. So kind of different years. Like, you have this big manufacturing company I talked at the very beginning. They have hundreds of tons of this dust waste. And this company, what they do is they use refillable glass bottles for their milk. And then, when customers are done with the bottles, they can return them to the grocery store, and the grocery store will send it back to the bottling facility where they'll, inspect the bottle, see if there's any cracks. If there's any cracks, they throw it away. If not, then they reuse it. So they'll throw away, maybe like 3 to 10 bottles a day. So not too many, a lot, they're able to reuse them, like up to 68 times is the average. But they generate about, 0.63 tons of glass waste annually. That's kind of a low estimate. And so this was maybe my biggest disappointment. I was really hoping that they would be able to crush this glass into sand and use this sand, on the facility. But it turns out sand is really dirt cheap if you're buying it bulk. It's about $8. So, well, closer than that actually. So 0.63 tons is $5 in savings. So I was like, nope, if you're going to spend about $9 grand on a glass crusher, you might want a little bit bigger return. So just going to send it off to local recycling facility that accepts glass. Fortunately, there's a couple good glass this company. So on to the second one. So they have caps for the glass bottles, and they're plastic caps. And about 20%, 33% of customers will return the glass bottles with the cap still attached. And they can't reuse these caps because they're like tamper-evident caps. And so there's a plastic rim that gets torn off. So you can't like put it on a new bottle again. So those throw it away. So it's about 500 to 1,000 caps that they'll throw away. 50,000 to 100,000 caps will throw away. So about 500 pounds, 2,000 pounds of plastic they send to the landfill. This project was a little bit difficult because it's not a ton of plastic. So like these big recycling companies that I contacted, they're like, sorry, we only take, 40 tons of plastic. And you guys have a quarter to half a ton. And so I've been trying to find some of the maybe local municipal recycling facilities who take it. Another difficulty is that's number 4 plastic, low density. It's actually linear low density polyethylene. So that's going to require a little more research to find out somewhere we can recycle this. Then the final one at the dairy products producer is the skim milk. So in the processing of milk, you separate your raw milk into cream and into skim milk. And the cream is the gold, as the dairy people say, because you're going to use that in your ice cream, you're going to use that in your butter. Obviously, you're using your whole milk at 2%. And so they're able to sell a fair amount of skim milk as well, or use it in 2% in whole and selling skim milk. But they dump about 600 gallons per week. So that adds up to about 31,000 gallons over the course of a year. It just goes into their waste water lagoon. So this one also is going to take a little more research to flesh out what they should do. But some of the best options would be to donate this to a local food pantry. I've been in contact with one that's interested. Of course, the glass bottles poses a little bit of an issue. So that's something that the facility is going to have to discuss with the food pantry. But there's also the benefit of the tax deduction from that. As Jacob pointed out, I'm not a CPA, so I actually don't know. I was doing a little tinkering, but I don't know entirely how much that would save. The other option is to give it to local farmers. Skim milk's kind of common, or at least popular, apparently, as a way to fatten up hogs. I don't know, I'm not a hog farmer, but this is what I read. And reading is cool. So anyway, kind of the last option would be to use it as fertilizer applied to the land. There's a little bit of research about that. It kind of came in vogue during COVID when farmers wouldn't be able to get it to their processing facility for some reason. So, all right, and then moving on to the last company I visited, the specialty vehicle manufacturer. And I did 3 projects with them as well. And so the first one is related to their chemical totes. So they'll put chemicals, of course, in their vehicles, antifreeze, diesel exhaust fluid, and another one's like windshield washer fluids. And so they'll pump them out of these big 275 gallon intermediate bulk containers. And the issue is that the pumps don't reach all the way to the bottom of these containers, as they leave an average of like 13 gallons at the bottom of these containers. So fortunately, that material isn't going to waste because they send the containers back to the supplier. The supplier just adds new material. So they're just paying for these 13 gallons again and again and again and again. And so that adds up. So you have about 14,000 gallons go unused by the company over the course of a year. So they can save that money by getting a little extenders. There's actually one area that within the facility that has an extender on their pump. So it'll help it get a little bit lower. And then the other option is you just have the employee go around after they're done with the pumps on the line and fill up and empty them out because there's a little valve at the bottom of the containers. So, yeah, so that would save about $36,000 per year. So the second one I did with this manufacturing company was their spray cans. They'll use hundreds of spray cans a year for various things, paint touch-up, insulating material, or WD-40. As they're making vehicles, they want it to be all looped up. So they use about 360 cans of WD-40. That's the most significant spray can, aerosol spray can that they use. And then the solution to this is to buy WD-40 with these other chemicals in bulk, and then get reusable spray cans where you can charge it up with compressed air or even a bike pump. Some spray cans can do that. It's kind of neat. And so just WD-40, switching that to reusable cans saves almost $6,000 per year. And spray cans are pretty light, so it only eliminates about 100 pounds from the cans of waste per year. But this is just from the WD-40 because I was having a little bit of difficulty. One of the other three main cans they use is getting discontinued, and I don't know what the facility is going to switch to in lieu of that. So I just was able to do it for the WD-40. But for the last project that I did, and last project I did with this vehicle manufacturer was their windshield glass. So they'll get the windshields shipped into them. And frequently there's some that arrive broken. So thus far in 2023, they've had a little over 100 windshields come in, and they're broken, they're cracked, so they can't use them. So they've started investigating and implementing ways to improve their packaging, prevent these windshields from coming in broken. They've talked to their supplier. And so that's already lowered the total because the objective for this year is 193 windshields, and last year, 2022, is 685. So my recommendation is that they recycle this glass. This prevents about 1.4 tons of waste, of glass going to waste. Of course, there's a little bit of difficulty because automobile glass, safety glass, what it is it's a plastic sheet, polyvinyl butyrol, and then it's kind of sandwiched by two sheets of glass. So that polyvinyl butyrol, hope I'm saying that right, that sheet makes it a little more difficult to recycle. So I'm still looking for a company that's willing to take that. Right, so then just a little side note at the end. One thing I encounter, especially at the manufacturing facilities, is just organizational issues. And by organizational issues, I'm also meaning kind of getting employees to buy in on organizing their waste stream or organizing their recycling. So this is at the cabinet manufacturer. And as I mentioned, they send their wood and even their particle board out to a wood shavings company for free. This is in their waste dumpster. And they also have cardboard recycling, but all this stuff ended up in the dumpster. A lot of this they can't do anything with, like this melamine. This is laminate coated wood. They can't shred that because no one wants formaldehyde in your wood shavings. I don't know, but so that's just kind of a side note. A common theme is a big issue facing manufacturing companies, just getting employees to buy in, and also thinking like, okay, what way can we encourage this behavior that we want? So then here's the summary, and this, just as it notes here at the bottom, the total numbers is just from the recommended, and I tried to note kind of the projects where a little more research is needed. With the plastic caps there, need to locate a recycler in the windshield glass. there's fair amount of savings available, especially with the dust waste there. About 182 metric tons of CO2 equivalent would get reduced. Oh yeah, no, then thanks to the PPI staff, you're all very helpful. Jacob and Lena, my supervisors, they're awesome. Then the host companies were all very gracious, having me come, ask them questions, pester them a little bit. And then my fellow interns, you guys are awesome too. I got to work with some of you. I did a couple side projects I didn't mention here, helping out some other ones. And my family, my little brother Jack over there. This for you, Jack. Yeah, so now I'll field any questions you guys have. So.
I'm mostly just out of curiosity, like you said, that you could send maybe limestone, I think it was, to solid to energy or waste to energy.
Yes.
Was it? Do you know how that happens?
I don't know. Yeah, it wasn't actually the limestone. It's the vacuum, dust that they pick up from the vacuum system. At least that was what the environmental manager at the facility was saying. He's talking to that company. That was his plan for having that waste. So maybe we could reuse it here. Save guys. Nancy?
I'll always ask a question.
Awesome.
I've been doing this a long time, so I love seeing these results and just, the different projects and progress that you guys make every year. It's awesome. I was really taken back by the skim milk because, feeding hungry people is really, really important to our program's been working in that area for a while. And so that has such a social connection to, not, societal impact. But I'm just wondering if we can't find some kind of outlet for that. And you said one of the food banks was maybe, I guess the biggest barrier on that is going to be the glass.
Yes.
And so if we can find a typical container, I hate to say plastic, because we try to get rid of plastic lids, not a plastic fan, but we know it transports, stores well, milk does. And we know that, Kroger and others for years have been freezing that milk successfully, but that takes space.
Right.
And then that's how the Kansas Food Bank distributes it, is they distribute that frozen milk out. So I'm just wondering if and I realize you're working with a small dairy.
Right.
And they don't have capacity. I think they've got a real hard for probably finding an outlet, no doubt. But they don't have capacity for storage there on site.
Yeah, it seemed like the best option. I was talking with the
And you might want
manager.
just some folks on Zoom can hear you.
I was talking with the manager at the dairy facility. And she was like, we're willing to do it. They're just gonna have to pay for the glass bottle deposit. Which I would assume that they, from what she was saying, they're willing to reimburse again when they get those bottles back. So that's definitely gonna be the difficulty. And I was like, yeah, maybe they could switch to using plastic or something. But I didn't really look into that much. For sure.
May I ask, is that in Riley County? Because there's some grant
Yes.
money that we might be able to make some connections with to
Yeah, I believe
that
they're in Riley.
project. I know it's near, isn't it Junction City or something maybe?
That's right. Yeah.
Okay, yeah, I bet we can find something for that, because I know they're super willing.
So that would actually be in a different county.
Okay, here. Okay.
Oh, that's right. It is in Gary. Thank you. Because I
Okay,
was looking at the Gary County Recycling Center. Yeah.
okay, cool.
Thank you, Mary.
For the plastic cans, did you suggest that they can switch to the recyclable cans like we want?
So when I was talking to their bottle and cap supplier, they are really wanting to switch the material. And I was like, well, are you thinking you might you'd be able to like buy it back or be able to recycle the material? And they're like, no, it's food grade plastic. We can't recycle it. I don't know.
Now we get water bottles that are with caps and.
So the caps are recyclable, but I was wondering if the company would want to take the caps back. That the company that makes the caps, I was wondering if they would want to take them back. They have some sort of program for that, but they do not. Was that your question? I'm sorry.
I mean, kind of.
Or a different material
Yeah.
that might even be reusable, right?
Yeah,
Would even be the best, but.
because most of the places, they don't take those.
Yeah.
Yeah.
No, I didn't really look into switching that to a different type of material or plastic. I must have just reached out to the company, but that's something that probably should have suggested to them.
Then learning that crushing those glasses is very expensive. What was the best thing that you learned out of all the projects? Your aha moment?
Well, I had a real difficult time getting a price for the magnet belt for the wood cabinet manufacturer. I originally had this estimate from this article from 1997 because I couldn't get any of these manufacturing companies to respond. And finally one did. It was like 8 times cheaper than my estimate. So I was like, because there was one that sent me this whole catalog of all their recycling stuff they do. And I was like, this is great, but it doesn't have any prices. So, or any costs. So that was a big one.
And it's a hard job what you were doing because we just don't have markets like we used to for some of these items. So you have a hard job in the research you did, a good job. I really enjoyed the presentation. I was pretty excited about the refillable spray cans. And I just think that's such a great application when it's.
It's all Jacobs. Thank you.
And, way to go. And we don't see it utilized as often as it could be. So thank you for bringing that up. The other part of the savings you didn't capture, this is just tuck away for our memory so we can maybe in the future, maybe think about doing this is you also saved those cans from having to be possibly punctured and managed, residual being managed as brick waste, which is very expensive. And so, you know, there was that part of it. That could be a savings depending on the size of the company as well.
Yeah, that was interesting. I learned a lot about if it's dry, then it doesn't actually count as hazardous waste. Or something like that, but they do puncture them, and so that would be a significant saving time-wise for employees. They don't have to